Paolo has worked a lot on this project, and I'll turn it over to Paolo.
All right. Thank you so much, Scott. Yeah, I think the mic works, but I'm hoping I'm loud enough, as it was pointed out this morning at Pete. So it's a pleasure for me to be here and talk about the next generation liquefaction project. Today, rather than focusing just on what we've done, we would like to open a community discussion and get feedback from the community about a project that was going on for the last few years. So I'm hoping that most of you are familiar with at least the basic of these community project. So the outline here, I'm going to talk about a little bit what the project is about and current needs for liquefaction hazard analysis. Then I'm going to present the next generation liquefaction database that's been published over a year ago. It's been populated and we are still working on it. Then I would like to talk about the laboratory component of the database. The database has been developed as a field investigation database. We recently added a component that has the capability of hosting laboratory test data. And I'm going to talk about cloud-based community access via different platforms. And then at the end, I'm not going to conclude, but I would like to open to discussion with the community. So I'll try to make the presentation a little bit briefer than what it is supposed to be, so that we have some time to talk about community needs. We have a lot of contributors. The leadership of the project is John Stewart, Steve Kramer, Yusuf Bozornia. We have a database working group that oversees the database population and review process, chaired by Scott Brandenburg, and we have individuals from various funding agencies contributing very meaningfully. We also have a lot of users and people actually uploading data into the database, including people from the University of Utah, Virginia Tech, UC Berkeley, BYU, Tonkin and Taylor in New Zealand, the Middle East Technical University in Turkey, and a lot of students from UCLA, and I'm happy to see many of those faces here today. We also have other collaborators from the US and overseas, so this is really a community effort. I'm going to show you the numbers in a second of how much it's been done, and there's still a lot to do. But as I said, this is a multi-agency community effort. Let me start by setting the stage for what I'm talking about. We are trying to model liquefaction effects on the built environment and the community, and the database hosts data about liquefaction manifestations or lack of manifestation, effects on structures and infrastructure and lifelines, and of course also regional scale impact, which is a big deal nowadays as we have more and better tools to actually perform post-earthquake reconnaissance. The project components are, of course, a community liquefaction and non-ground failure database. This is going to be the bulk of this presentation, and as I said, we are in the phase of populating it. That data points are vetted, are reviewed by reviewers, and this review process is overseen by the database working group. We have and we fed supporting studies of critical effects that are poorly constrained by data. So these are focused studies. And then down the road, there's the model development. So we'll have NGA type approach with team meetings, common resources, shared data, of course, and model over certain parameter space. The organization of the project is sketched here with a joint management committee with representatives from key organizations. We have senior advisors, an advisory board, the project management committee with Professor Kramer, Stewart, and Bozornia, the database development team that I was talking about, some focus studies. We fed some we will have more. And here with the dashed line, model development, which is the component that is going to happen after we reach a critical mass of data. The database, as I said, it was online. It's been online for more than a year now. Last year, at the peer annual meeting, we just published it. We have a DOI. It's accessible at nextgenerationliquefaction.org. Anyone can create an account, download the data, work with the data, upload new data. So it's fully operational now. And as you can see here, we have a nice overview of all of the sites that's been uploaded in the database. And of course, all of the earthquake events that triggered liquefaction all over the place. As I said, the population process is still ongoing. I'm going to show you some details about it in a second. Now, let me take a step back and let me define what we're talking about. And this has been something that we've been talking about a lot within the community. What do we define as a site in the NGL context? So we came up with this idea that the site is a high-level entity into which data is organized. It shows as a single point on a map. However, this doesn't mean that the site is a punctual entity, is a point. It can be interpreted as a broader area. So we only have a point on the map. You'll see the site as a point for convenience, for plotting. But it doesn't mean that's a point. It's an area. I'm going to show you a little bit more about that. And then, of course, we have geotechnical conditions and observation that may vary spatially within the site. So there's some judgment that users need to exercise in assigning a point to a site. We have examples of sites where we have one liquefaction manifestation following a certain event and one profile, in this case, a compenetration test profile that is co-located with observation. So this is very simple. It's a point on the map, and it is actually kind of a point, more or less. We have more complicated sites, like this one from Japan in the Mihama Ward area following the Tohoku earthquake. The brownish lines and the circle represent liquefaction surface manifestation. This is a very interesting case history because we have a variable performance of soil over a short length. This is reclaimed land, so it's a potentially impactful case history for susceptibility. This is not a point. However, it is shown as a point in the NGL database graphical interface. But you know, that pinpoint is just to represent that site. The site is actually an area where, as I said, we have multiple observations across the whole site. We also have within the site multiple field and laboratory tests. And in red, I'm showing points with field investigation tests. So the database has a flexibility to host both single point sites and geospatially distributed data sets. The current status, as you can see, we have a lot of liquefaction observations and non-liquefaction observations. We have a number of compenetration tests, boreholes, surface wave measurements, and invasive shear wave velocity profiles. This number is growing constantly every day as new data is added. Most of it is new data that hasn't been used in past models. We have a review process for each piece of information that has to be reviewed by 2 reviewers. Most of the sites are currently under review. More than 20% has been already reviewed, and it is flagged as reviewed in the database. As I said, the population and review process is formally overseen by a working group chaired by Scott. How do we access the database? You can do that via graphical interface, and you can download the data. However, if you want to do more complex and more advanced computations, you can actually access the data in the cloud because we are replicating the entire database daily into servers at Design Safe at the University of Texas at Austin. So we also developed a number of cloud-based tools that users can use to interact with the data and as a guidance to develop new tools to post-process the data. We created so-called partner data apps that are accessible from the Design Safe homepage. And as you can see here, we have a number of Jupyter notebooks that are fully open to anyone to use and modify for viewing and working on CPT data, compenetration tests and standard penetration data, shear wave velocity profiles, and so forth. This is just a screenshot from the CPT compenetration test viewer. As you can see here, you can do a number of things. You can plot the data, you can show cumulative distribution of the data over a certain length and so forth. And of course, you can query the database as you wish. It's fully open to users via cloud. You can't write anything, but you can read everything in the database. We added recently a laboratory component. This is a slide from a poster that was presented yesterday by Ken Hudson. We have index tests, grain size distributions, but of course we added recently triaxial tests, direct simple shear, and potentially other tests. And this will be one interesting talking point. What else can we add as part of the laboratory component of this database? Ken created also some tools to interact with laboratory tests. This is for triaxial tests. As you can see, it's again a Jupyter notebook. This is not published yet, but it's going to be published soon. We are cleaning it up. The code is going to be available as well as a graphical interface. So again, you can use it as a guidance tool to perform post-processing analysis. Here are another screenshot from the same tool. And then going back to the definition of a site, as I said, we can host geospatial data set. And more, we are going to see geospatial models like the one by Zhu et al. That I'm plotting, developed by Lori Base's research team. For performing analysis using these geospatial models, you require additional layers, such as geology maps, groundwater table maps, etc. Every single of these maps can be added to the NGL database via supplemental files or DOI, which is a digital object identifier that points toward the specific web location. This means that the data doesn't need to reside within the database. It can reside somewhere else, like Design Safe, for example, but you can use the data and import the data as part of the NGL processing tools, and soon we are gonna have that implemented also in the graphical interface. Examples of geospatial visualization tools in Design Safe with NGL data is these liquefaction area at a railroad track in Argus after the recent Ridgecrest earthquake in July. As you can see here, we have 3 orthomosaics that have been created using remote sensing tools. We have high quality images here, and of course you have here a geology map. So you can combine all of these layers and you can interact with the data, and you can do much more than these with new tools that are becoming available. You can also visualize 3D point clouds. This is a 3D point cloud built from drone images of a liquefaction surface manifestation following the 2019 Ridgecrest earthquake. This is showing a screenshot of the 3D model by using a tool in Design Safe in the cloud. It's an open source tool called Po3. Essentially, you can import many gigabyte worth of data, visualize it, and link it to sites that are in the NGL database via DOI or other equivalent means. That means that we are now expanding the horizons of liquefaction analysis to a whole new level that can include different ways of looking at damage and, of course, modeling. As I said, the graphical interface is currently improved to host these additional layers, so you could soon enough, hopefully, visualize external layers, geospatial data as part of the graphical interface by just clicking on a menu that we are envisioning putting on this panel. All of the data sets are going to be unchecked by default. Many of those I expect are going to be global layers, but you can zoom in and check the ones you require for the specific analysis you are doing. By doing that, these will facilitate efforts of understanding better what occurred after an earthquake, and of course, as more high-quality data becomes available, we can do a better job in modeling liquefaction hazard analysis. This is my last slide actually, so I'm hoping I'm still on time, so we have some times for discussion. We have some talking points here, and of course we can expand, and we would like to receive some feedback and some comments from the community, because we would like to improve these tools and make sure that we are not forgetting anything. So for geospatial models, for example, what layers do we need to add? And what kind of formats? GeoJSON, shapefiles, something else, because this is something that we're working on, and we would like to provide a tool that works for the people that are going to be model developers or users. Laboratory component, what are we missing? Are there additional test types that we don't have? What about available lab test data sets that we can actually, that is publicly available and we can add to the database? Is there anything there that is low-hanging fruit? We would love to hear that. And of course, for the upcoming model development phase, there's going to be new tools. We are envisioning to have alternative ways of performing analysis, including artificial intelligence. So is there anything that model developers would want to see to implement such tools? And of course, is there any specific gaps or needs that you see that we can implement? This is a perfect time to talk about it, we believe, because the database is there, we have a critical mass of data, and we are in the phase of improving it and making sure that it's going to be ready for model development. So I would like to open the discussion. There's some relevant references here, and of course, check it out, the nextgenerationliquefaction.org database visual one. Thank you.